Hello dear students, welcome you all. Well, in this lecture, I am going to discuss about the properties of leptons, right? So, in the earlier lecture, I have discussed about the classification of elementary particles, and you know very well that what are leptons, right? I told you that leptons are basically fundamental particles. They are also elementary particles, but they are fundamental. It means they don't have any substructure. They are, the smallest particle that cannot be, divided further. And the group of lepton have 6 members. Electron, right? You can see here, muon and a tau particle, and we have a 3 neutrino associated with these 3 particles, right? E, mu, tau. You can see here. Now, these 6 leptons are divided into 3 generations. Generations means it is the way of detecting these leptons, right? And you can see, and it is also according to their mass. You can see here in the first generation we have electron, so it is an easily detectable particle, easily observable particle, right? This is electron first generation, and electron neutrino is associated with it. So these 2 particles are in the first generation category particles. Their symbol is E negative. You can see here mass is given here. You can see mass of the electron, and it is the mass in terms of energy. We know mass is equal to E upon C square. So you can see here it is 0.511 for electron, 0.511 mega electron volt upon C square. In some books you may find that this mass is equal to 511 mega electron volt. In that case, C is taken as 1, because in high energy physics we take system of natural units where h cut is equal to C is equal to 1. So in that case it can be the thing that you only find 0.511 mega electron volt, but here you can see C square is also present, right? And as far as electron neutrino is concerned, earlier it was believed that they have 0 rest mass, but with the advancement in high energy physics, and we have modern particle accelerators, now it is found that they have a very small mass of the order of 0.8 electron volt upon C square. You can see here 0.8 electron volt upon C square. This is the mass of these electron neutrinos. Their symbol is this. Their charge is 0. They are fermions, means spin half. Electron are also fermions, spin half, right? Now, if you come to the second generation, muons, right? Muons are heavier than the generation of the first generation particles. I mean electrons. You can say here that the mass is 1.884 into 10 raised to power minus 28 kilogram. In terms of energy, it is 105.7 mega electron volt upon C square. You can see here. So it is higher than this one. Their symbol is this, charge -1 and spin half. Now the neutrino corresponding to muons is known as mu neutrino. That the mass of that neutrino is this one, same to this one. Symbol is this. Their charge is also 0 and spin is half. So these 2 particles are in the category of second generation leptons. Now I am coming to the third generation, right? This is second, this is first. In third generation, you have a tau particle, right? And tau particle is very heavier as compared to electron. You can see here 1777 mega electron volt upon C square. And in terms of kilogram, 3.168 into 10 raised to power minus 27 kilogram, right? So it is very heavier as compared to electron. Symbol is this one, charge is negative, spin is half, right? And you can see here even the this valence, as you proceed toward this side, the valence is going downward, means the mass is increasing toward this side. So So it is very heavier as compared to this one. But in case of neutrino, the mass remains the same. The valence is at the same position, right? No change. And this is this tau particle and tau neutrino. They are known as the leptons of third generation, right? So this is the classification according to their mass, energy, electron charge, and spin. Right now I am coming to one by one all of them. If we talk about the electrons in details, we know very well what is the charge on electron and what is the mass and energy, the spin, right? If we talk about the magnetic moment of the electron, then we know magnetic dipole moment of electron is equal to E h cut upon 2me, right? That is equal to 9.27 into 10 raised to power minus 24 ampere meter square. We call it as electronic Bohr magneton, right? Now, as far as the lifetime of electron is concerned, now electron is a stable particle and it has a lifetime of around 10 raised to power 28 years. Very long lifetime, right? You can say that this particle is fully stable provided it does not meet with the positron, right? If it meet with the positron, electron get a positron, then it converts into 2 gamma rays, right? Positron is known as the antiparticle of electron. Particle and antiparticles are same kind of thing. They have only one property opposite to each other, but the other properties are same. The property can be charge, it can be spin, it can be magnetic moment, it can be lepton number, it can be virion number, strangeness, hypercharge. All these property can be different, but only one property will be different out of all these properties. Other property जो है वो same ही रहेंगी, वो change नहीं होंगी, right? So this is the concept of antiparticle. So जैसे मैंने बोला कि electron is the most stable particle in the universe. Even proton, if we talk about the proton, then proton has a lifetime of around 10 raised to power 32 years, right? मैंने क्लास में भी कई बार बोला कि ये जो दो पार्टिकल है ये बहुत ही लॉन्ग लिव्ड पार्टिकल हैं. दे आर कुछ जो इलेक्ट्रॉन्स और प्रोटॉन्स हैं, दे आर स्टिल मेड इन द बिगिनिंग ऑफ द यूनिवर्स, और वो आज के आज वैसे ही है. क्यों? बिकॉज देयर लाइफ टाइम इज वेरी वेरी लार्ज, वेरी वेरी लॉन्ग, प्रोवाइडेड अगर उनको कोई एंटी पार्टिकल नहीं मिलता है. मेरा बोलने का मतलब कि वो स्पॉन्टेनियसली दे विल नॉट अंडरगो एनी काइंड ऑफ डीके, जस्ट लाइक अदर पार्टिकल्स. ये अपने आप डीके नहीं होंगे. अगर कोई दूसरा पार्टिकल मिलता है, इन दैट केस दे कैन कन्वर्ट इनटू अनदर पार्टिकल, बट they are otherwise stable, right? So this is the properties of electron. Now I'm coming to the properties of muons, second particle. Muons. As I told you that this particle is represented as negative and its antiparticle is a mu positive. So these particles were discovered by C.D. Anderson and S. Larimer in 1937, right? C.D. Anderson and S. Larimer in 1937, right? These both particles have charge equal to the charge of electron. This has positive and this has negative. Both of them have spin half integral, means they are fermions, right? And this particle is the antiparticle of this one, right? Now how these particles are produced, right? These particles are produced in the decay modes of other particle. For example, when pi negative particle decay, it convert into mu negative plus this one, neutrino associated with the antineutrino. Similarly, in the decay of pi positive meson, we get a mu positive plus neutrino associated with this, right? So I told you about the mass, spin, right? Production, their magnetic dipole moment will be obviously because their mass is higher than the mass of electron. So their magnetic dipole moment mu that will be equal to 1 upon 208 time magnetic dipole moment of electron, right? Because their mass is higher, right? Now, if I talk about the decay modes, right? These both particles can undergo spontaneous decay. So mu negative can go to electron plus neutrino, plus electron plus neutrino associated with mu 1 plus electron anti-neutrino, right? This is one. And similarly, mu positive can also undergo decay, positron plus neutrino, anti-neutrino associated with mu 1 plus neutrino associated with the electron. So this is the decay mode of muons, right? Now, as far as the third type of particle, that is tau particle, right? I told you that tau particle is represented as tau negative, right? It has an antiparticle, that is tau positive, right? So spin half integral, right? Their mass is written here. They are heavier than electron and muons, right? Charge is equal to the electronic charge, right? And mass is also given there, right? Now, the decay mode. I'm talking about the decay mode of these particles because they are very important in exams. Examiner can ask you that you discuss the properties of lepton and also discuss their decay modes, right? These particles, tau particles, are so unstable. They have a lifetime or half-life period of 3 into 10 raised to power minus 13 second, right? Just like muons, they are also unstable. Muons have a half-life of, I am writing here their half-life, 2.2 into 10 raised to power minus 6 second. This is the half-life period of muons, and tau particle has half-life period of this much. They undergo decay according to this rule. Tau negative will convert into mu negative, muons negative plus neutrino associated with muon, anti-neutrino plus neutrino associated with the tau particle. Similarly, tau positive particle will convert into muon positive, right, plus muon associated with the, sorry, not muon, but anti-neutrino associated with the, again I am writing it wrongly, neutrino associated with the muon plus neutrino, anti-neutrino associated with the tau particle, right? So these are the decay modes of these particles. These particles participate in both electromagnetic as well as in a weak interaction. However, these particles never participate in a strong interaction. This is very important. These particles participate in a, I told you, weak and electromagnetic interaction, but they do not participate in a strong interaction, right? Muon particle, these particles also participates in the same type of interaction, that is electromagnetic and weak, right? As far as electrons are concerned, I am also writing for them. They also participate in electromagnetic and weak interactions, right? They do not participate in a strong interaction. So all the leptons participate only in weak and electromagnetic interactions, right? Now, these are the properties of electron, muon and tau particle. As far as neutrino are concerned, we know very well neutrino. I told you that neutrinos are the particle, that has a rest mass very small as compared to the mass of electron. You can see here their charge is 0, their spin is half integral, and these particles are basically produced inside the atomic nucleus when there is a conversion of a neutron into proton plus electron plus anti-neutrino associated with electron. So they produce in this type of reaction, or otherwise we can have a reaction proton plus convert into neutron plus positron plus neutrino associated with the electron, or even electron capture proton plus electron, that will give you neutron plus this one. So this is the way of the production of these neutrino particles, right? These particles are highly stable and they have very low interaction with the the matter, right? Their spin is half integral, right? They are stable particles. They never decay into another elementary particles. They have no substructure. They are fundamental particles. These particles participate only in weak interactions. This is very, very important. They participate only in weak interactions, right? So these are the properties of these neutrinos. And as far as their other properties are concerned, they are written here, and they don't have any of the neutrino, whether it is electron neutrino, whether it is neutrino associated with tau particle, or whether it is neutrino associated with the muons, right? All of them have a same property. I mean, all of them are a stable particle and they do not undergo any kind of decay, and they are produced due to the decay of leptons, the E, mu and tau leptons. When E, mu and tau either decay or they are produced in any reaction, they are produced along with, right? And other properties are same. So this is all about it, and all these neutrino participate in only weak interaction, right? So this is about the all properties of these leptons, right? So I discussed all of them one by one, right? Now examiner can ask you about the properties of leptons in detail. So you have to answer this question in this way, right? You can draw a table. In table you can write down the different generations of lepton. Then you can come to all of them one by one, starting from electron, right? Electrons, muons, then neutrinos, and then tau particle, and then neutrinos, right? So thank you very much.